Secretary, ma'am of IEI Salem local chapter, and all others who have joined this session. Good evening to one and all. It's my great pleasure to introduce Manoj Matthias, a senior research grade 1, currently working at Nanyang Technological University in Singapore. Manoj has joined as research associate in 2018 and holds a tie-up master's degree in aerospace engineering from both Technical University of Munich and Nanyang University during 2014 to 2017, and he has completed his bachelor degree in aeronautical engineering at Kapagam Institute of Technology, Coimbatore during 2013. With a strong technical background, Manoj had made significant contribution in the realm of sustainable solution and recycling efforts, particularly focusing on material characterization for sustainable energy generation. His expertise extends to a green energy initiative, especially targeting marine environments and remote coastal islands. His innovative work has resulted in 28 technological disclosures, nearly 22 applied patents, and close to 20 publications in reputed journals. And we are excited to have Manoj Matthias to join us and share his knowledge at this webinar. His expertise will add a lot of our discussion and help us to learn more about sustainable energy technologies. And we are looking forward to have a great session with Manoj. Thank you. And I think I can hand over the session to Mr. Manoj.
Thanks for giving me an opportunity. Hope my screen is visible to everyone.
Yeah, I think it's visible.
Yes, sir. Visible, sir.
Okay, thank you. Thank you for giving me this opportunity on this evening occasion. And today I would like to share some of my expertises as well as my experiences, what I'm going through on the sustainable aviation. So I'm actually working on sustainability as well as more towards the energy. So this presentation and this lectures is going to consider more about the sustainable solutions, like how the environment is getting affected and how we are doing some sustainable solutions to bring back the environmental back to its normal conditions. So for that, what I have chosen today is sustainable aviation, because aviation industry is actually being affected by more of the fuels. For example, currently the turbine fuels, what we are using accounts for more carbon dioxide emissions. So for the initiative sustainability, what sustainability is? So sustainability is the balance between the environment, equity, and economy. So when the sustainability is affected, for example, if the environment is affected, total commercial products are getting affected, even the human resources are getting affected, and all the animals, everything is getting affected. So more balance is being maintained for maintaining the sustainability. What are all the key environmental issues that affects the environment? So those are like resource depletion, pollution, waste, deforestation, loss of biodiversity, and climate change. And the aviation industry comes under three categories, more like resource depletion, pollution, and climate change. How it comes under, we'll go through in the further slides. Also, I would like to share something about the sustainable goals, what other countries are focusing on. So there are like 7 SGD goals. What is the SGD goals? Is like sustainable development goals. Each and every industry, for example, food industry, aquaculture, marine, normal mechanical industries, everything has a separate sustainable goals under each numbers. So these numbers represents the sustainable goals for every industries. So every industries are nowadays focusing towards their own sustainable goals, and they are trying to achieve it. So in that way, how our sustainable solutions can be provided towards the aviation industries, that we will focus here. So as I was mentioning, the aviation industry alone contributes about 2.5% of the global carbon dioxide emissions. How it commits? Because the pollutant created by the turbine fuels generates these amount of carbon dioxide emissions, and it changes the climatic impacts. In the climate impacts varadhanala, what happens? It increases the global warming. So the global warming contribution is really affected by this turbine fuels. So that is where we have to take some necessary actions to reduce the amount of carbon dioxide emissions that is being generated by our aviation industries. So what currently aviation industries are focusing on? There are three different key areas where the aviation industries are focusing on. One is on the sustainable materials. What is sustainable materials? These sustainable materials are nothing but bio-environmental materials which are obtained from the environment, what we are seeing daily. For example, trees learn the fibers and different kinds of composite materials. So all renewable materials and recycling materials are being introduced to the aviation industries at different locations of the aircrafts, and thereby they are recycling it rather than sending it to the end of life. So அதை வந்து ஒரு இன்சினரேஷனுக்கோ அந்த மாதிரி டம்புக்கோ நம்ம அனுப்பாம they are trying to recycling it, based on which they are increasing the end of life of a product. Once we reduce the end of life, once we increase the end of life of a product, then the sustainability comes in. So that is where we are more focusing on materials, what we are using for the aviation industries. So for example, aircraft like different parts comprises of different kinds of materials like aluminum, composites, and different things. So nowadays more like bio-based materials with self-healing properties are being introduced to reduce the end of life. So that is where the sustainable material comes here. So the next category what I was talking about is propulsion. So propulsion is a key area where we can reduce a lot amount of carbon dioxide emission into the atmosphere. So that is where we have a sustainable aviation fuels which are coming in. What is these sustainable aviation fuels? What are all the types of fuels? What we can say it as a sustainable aviation fuels? So these are these sustainable aviation fuels are being used only for the aviation industries? No, it is being used for all the regular automotive industries and other machineries. எல்லா இண்டஸ்ட்ரீஸ்க்குமே இந்த மாதிரி fuels வந்து யூஸ் பண்றாங்க. But for our aviation industry, we more focus towards the standards. What the CAS or the aviation standards are looking for, we will just provide these kinds of fuels according to their requirements and their standards, based on which they will approve it and they are being used in the current industries. So are we using any SAF? Yes, currently there are some SAF being used in the aviation industries. Those are like biofuels and less carbon emissive synthetic fuels. So what are synthetic fuels? Synthetic fuels are nothing but gasoline, diesel, and kerosene. So இந்த மாதிரி மெட்டீரியல்ஸ் எல்லாம் வந்து இந்த மாதிரி fuels எல்லாம் வந்து பார்த்தோம்னா now they are trying to blend it with commercial products where we can reduce the amount of carbon dioxide emission after they are being used or after they are being burnt. So that is where these synthetic fuels are also being used as a sustainable aviation fuels. And then comes the biofuels. What are all called biofuels? Biofuels are nothing but fuels that are generated from the leftover or any waste that is occurring in the environment. ஒரு என்வாயன்மெண்ட்ல இருக்க ஒரு என்வாயன்மெண்ட்ல இருக்க வேஸ்டோ அல்லது லெஃப்ட் ஓவர் ஃபுட்ஸ், அனிமல் ஃபீசஸ் அண்ட் ஆல்கே க்ரோத்ஸ் அண்ட் இதை வச்சு நம்ம வந்து ஜென்ரேட் பண்ற ஃபியூவல்ஸ் ஆர் நோன் எஸ் த பயோஃபியூவல்ஸ். These biofuels are really getting a very good appreciation in the field of automotives or as well as in the aviation industries. Why? Because these are biodegradable and the amount of carbon dioxide emission from these fuels are really very less. So that's where these biofuels are playing a key roles. So how about other kind of propulsions? For example, battery based money nowadays they are doing hydrogen, and there are so many different kinds of things where we can go without fuels. Yes, that is true. But can they sustain for a long time? Definitely not. So that is where these sustainable aviation fuels are giving a handshake to those industries. Thereby, they can co-join together to work for reducing the amount of carbon dioxide emission throughout their journey. So that is where some of the aviation fuels are coming up. And as I was talking, there are some other options like batteries and hydrogen generations. So are they being used for long haul? No, currently they are not being used for long haul, because either a hydrogen that is alone can sustain for a long term, cannot, or a battery alone can sustain for a long term or long haul operations. No, they cannot. That is why we need some co-generative solutions to run a battery with a biofuels or a hydrogen with a biofuels. Why these cannot be used? இதெல்லாம் ஏன் நம்மளால யூஸ் பண்ண முடியல அப்படின்னு பார்த்தோம்னா, the weight of the battery will remain the same, which I will be telling what are all the limitations, why we are not able to fully sustain with the battery, or why we are not able to fully sustain with the hydrogen. So those things I will be telling at the last. But can we overcome this? Yes, definitely we can overcome these solutions. So is hydrogen an option? Definitely hydrogen is a good option. Why hydrogen is a good option? Because once you burn the hydrogen, there is no byproducts coming out from the burnt. So that is why we call these hydrogen as a clean energy solution. So when we use it in our aviation industry, once these hydrogen are being converted into an electrical source, they do not emit any kind of carbon. So that is where they call it as a very green solution or zero emission solutions for locomotives, like automotives, locomotives, as well as the aviations. So the commercial hydrogen aircrafts are need to be developed, because currently we do not have any hydrogen powered aircrafts to run for a commercial solutions. So there are no commercial aircrafts currently running with hydrogen, but they are being developed by Airbus, Boeing, which I'll show you in the upcoming slides. And as I was mentioning, we also need to develop a solution for long haul operation as well. So long haul operation, we are currently developing the solutions. So what I'm working on, I'm actually working on a hydrogen generation as well as hydrogen storage, and compressing the hydrogen gas to store it in a composite cylinders and to use it for long operations in a automotive industries. That is where my current area is. So as we compare it with the cost of synthetic fuels, these hydrogen cost will definitely get reduced in the upcoming period. Currently on the Pathamna, it is only in the developing phase, but by 2050, the amount of hydrogen or the cost of hydrogen will be definitely be reduced, and the amount of hydrogen being used will get increased. So that is a good initiative what we are being doing now. And what this actual hydrogen is, hydrogen, how we are producing hydrogen, and why we say hydrogen is a clean energy and we do not find any kind of carbon emission from this. Yes, there are some reasons, because we have a natural gas. Nama natural gas extract pandra, one of the key element is called hydrogen. So this alone is like contributing 75% of the entire mass of the universe. That's how we are utilizing this hydrogen to use as a fuel to run an aviation or transport or all the kind of things. Even for buildings, we are trying to develop hydrogen energy storage system to run a solar buildings. So these fuels, after they are burnt, they do not have any kind of breakage of bondings. So once there is no bond breaks happening between the so there will not be any kind of byproducts coming out after they are burnt. So that is why we call these hydrogen as a clean energy solution. So we also have different kind of hydrogen generation methods, which I'll be telling as well. So why this hydrogen? Why we are focusing more on hydrogen? Because they are an excellent energy carrier compared to a normal battery. Okay, this hydrogen is has a higher energy density, where they can store the energy in the form of hydrogen, and later they can be extracted using a fuel cell. And these are clean fuel with zero green gas emissions. Also, they are diverse domestic sources. As I was mentioning, it is adversely available in the environment. So abundantly, it is abundantly available, we can utilize these sources to use it as a fuel. and economically competitive. As I was mentioning in my previous slide, compared to the synthetic fuels, these hydrogen fuels is going to cost less compared to the synthetic fuel in the upcoming future. Better security than other commercial fuels because they are very safe to use until or unless they are getting burnt. Until or unless they are getting burnt, there is nothing to worry about a hydrogen that can be stored in a cylinders. It can be stored in the form of liquid, it can be stored in the form of gas, and it can also be stored in the form of solids. So solids, we have hydrates in the form of gas, in the form of liquids, we are currently storing up. And faster refueling time than battery vehicles. Yes, as I was mentioning, it is being stored in a composite vessel. So where we can refuel it as soon as possible with high pressure, and we can maintain it for a longer haul. So clean aviation now aims to mature, demonstrate all kind of these solutions in the form of liquid hydrogen and fuel cell distribution inside the propulsion drive. So based on which these propulsion drives will be running on hydrogen fuels. How these hydrogens are produced? Okay, so this is actually a key, one of the key area what people are working on. And how the hydrogen is produced. Is the hydrogen is only one form? No, actually the hydrogen is produced from different kinds of sources. For example, as I was mentioning, there is a form called natural gas. There is hydrogen produced from the water. Hydrogen is also produced from waste, what we have in the general days. So like there are different names given to these hydrogens, like green hydrogen, gray hydrogen, and blue hydrogen. What kind of hydrogen can be used for aviation industries? That I will give you in the next slides. So possibly blue hydrogen is nothing but a hydrogen that is generated from water source. So ஒரு வாட்டர்ல இருந்து ஜெனரேட் பண்ற ஹைட்ரஜனை we call it as a blue hydrogen. Wasteல இருந்து ஜெனரேட் பண்ற ஹைட்ரஜனை we call it as a gray hydrogen. And from renewable sources, whatever we produce, we call it as a green hydrogen. Even from the natural gas, what we produce can also be a green hydrogen, also be a gray hydrogen. Why we say we call it as a green hydrogen and gray hydrogen? Because natural gas la vandu patamna, it is a composition of methane, hydrogen, and other compositions. So methane வந்து crack பண்ணும்போது, when we decompose the methane using a possible solutions like steam methane reforming or a pyrolysis method, we create the hydrogen, like we split the hydrogen and carbon. Based on that part, the hydrogen is being generated from the natural gas. So in the form of water, what we are doing is we are breaking the hydrogen and oxygen. So when you use water to generate a hydrogen, the outcome of the hydrogen generator will be a hydrogen and oxygen. So we get hydrogen separately and oxygen separately. Also, in some of the fuel cells, when we give this hydrogen as an input, we get the output as a water. This water is also being recycled and used for different industries. For example, air conditioning system and other heat transfer systems. So that is where we call this as a very, very clean solution. So these clean solutions need to be adopted for our own industry. That is where we can show that our industry is very clean and it can generate more revenues with a zero emission. So what are the pathways of hydrogen? So the green hydrogen and the fossil fuel hydrogen. What we do with the green hydrogen? There are renewable sources like solar, wind turbines, tidal turbines, thermal energies. So these are some of the renewable energies what currently available in our market. So we can use these renewable energies to power these splitting sources. For example, electrolysis or the pyrolysis. So any kind of methane resources. So any kind of solutions. இதெல்லாத்தையும் power பண்றதுக்கு we need some kind of energy. So that energy can be derived from a renewable sources. That is where we call it as a green hydrogen. Or when we use a grid, we call it as a normal hydrogen or a blue hydrogen. So when we use a normal hydrogen, the carbon emission, we have to even include the carbon emission from the grid solutions. So the grid is produced from the fossil fuels. So that is where we call it as a fossil fuels as an input, energy input for steam reformations. So, how we can use these hydrogens in our aircrafts? These hydrogen can be stored in a composite vessels or composite storage materials, and we can utilize them with the aircrafts. So we can install these vessels inside the aircrafts, but current limitations are storing up a huge kind of vessels inside the aircrafts. So now the aircraft need to be redesigned. அங்கதான் நம்மளோட பெரிய issues இருக்கு. The limitations are coming up because we just bring the vessels inside the aircraft. But does that vessel alone can generate energy to run an aircraft? No, we need some more resources like fuel cells and some electric motors to drive the power from the hydrogen and to run the motors and the turbines. So அப்பதான் நம்மளால வந்து தேவையான அளவுக்கு எனர்ஜியை வந்து ஜென்ரேட் பண்ண முடியும். So that is where we use the fuel cells. These fuel cells actually split joints with the hydrogen and oxygen, and they create the water as a solution. So in that case, when the movement of electrons are happening, the energy is being generated. So this fuel cell is mainly to generate the power source, electric source. This electric source will be used to run the propulsions. So what are the benefits of fuel cells? Here we are using these fuel cells, but what is the outcome? Just a water. As you see here, when you input hydrogen, the output is just a water, because one side we input hydrogen and the other side we input oxygen. So only byproduct from this fuel cell will be hydrogen. Other than that, we don't have any kind of carbon or other emissive gases from these fuel cells. So they are very zero emissive solutions. Also, these fuel cells are more efficient than the conventional engines. So high-grade waste from the system can be used for cogeneration, heating, and air conditioning system. As I was mentioning, as we get water as a byproduct from these fuel cells, we can use these waters to run the air conditioning system or to cool the heating systems and other solutions. And these fuel technologies really meets the demand for clean and quiet and efficient powers. We have seen how these fuel cells and where we are going to store the hydrogen and stuff, but how this hydrogen fuel cell exactly works. So when you see this cluttered wires, this is what called as a fuel cells. So these fuel cells are stored near the propulsive area. So when these are stored in the propulsive area, these need to be run through a electric driven motors. Electric driven motors இருந்தாதான் இந்த propulsion வந்து நம்மளால generate பண்ண முடியும். அப்போ we need so much of wire and so much of connections to be done to drive energy from the fuel cell and to run the electric motor. So for that, we need these fuel cells. So this creates a overall complex solution. இங்க தான் வந்து நமக்கு தேவையான அளவுக்கு cooling sources தேவைப்படும், because we have so much of energy generated from this solution. So we have so much of heat is also being extracted from the solution. In that area, we use the byproduct liquid, that is water, to cool these solutions. So அததான் நம்ம இப்ப பண்ணிட்டு இருக்காங்க. Also, the limitations of the current battery powered and hydrogen powered. So the battery powered on the patamna, it is like 30 times more than the current jet fuel intake. Once in the current jet fuel intake, once the fuel is getting burnt, the total weight of the aircraft will get reduced. But in case of a battery, when the battery is being drained, the overall mass is going to stay the same. So in that area, when we consider, the overall payload and overall weight of the aircraft will remains the same during the entire operation. In case of hydrogen powered aircraft, it has a high energy by mass than jet fuel. It has lower energy by volume than jet fuel. So do we need the exact amount of jet fuel what they are using currently and commercially for the hydrogen? No, not necessary. Because as I was mentioning in my earlier slides, the hydrogen has a high energy density, and they are called as a high energy density carrier. So in that way, we can just need a lower amount of energy than the jet fuel, but the amount of hydrogen needed to generate the power for driving an electric source is much higher. That is where the limitations come for the hydrogen aircrafts. Producing hydrogen at a scale can affect carbon footprint. So when we see, I was mentioning there are different types of hydrogen being generated in the current commercial solutions, like green hydrogen, blue hydrogen, and gray hydrogen. Only green hydrogen has a less carbon emissive solution when generating a hydrogen because they use renewable sources to generate hydrogen. But in case of a blue hydrogen or a waste hydrogen, that is gray hydrogen, we have some carbon emission occurring during the generation, not when they are being converted as an energy. So that part has to be focused a lot because we cannot be using the green power for producing hydrogen at a large scale. So we might need some fossil fuels also to generate hydrogen at a large scale. That is being taken as a limitation currently. So, what our future sustainable aircrafts are going to look like, and what are they going to focus on? Sustainable aviation fuels will take over by 2050, and this is going to play a major role in the aviation industry by reducing the carbon emission for about 200 million tons, and battery powered aircrafts to be used in the military missions. Currently, NASA is focusing on battery powered aircrafts being used for the defense solutions. Also, vertical takeoff and landing prospects are being done. And air taxi is also a biggest solution. What is going to come up by 2025? Even in Singapore, we are going to get an air taxi, and the basic testing has been completed for the air taxi, and it will be on trials from 2025. So more of the unmanned aerial vehicles, which we are being focused with electric sources. And hydrogen powered aircraft comes as a last, but this will take up as soon as possible when the carbon emission will be focused to a zero emission solutions by 2050. So that is where people are more focusing on. So what is going to happen next when these solutions are being implemented? So as I was mentioning, SF is going to play a major role, and hydrogen aviation is coming to an airport which can be near to your airport wherever you are staying nearby, and to the commercial airports, as well as the first movers will definitely get some position. What this statement defines, because we as engineers need to come up with good solutions and good creativity to overcome these limitations. As I was mentioning, there are so many limitations for using the hydrogen source as a carrier for the aviation industry. So we should come up with a possible solutions to overcome all the limitations. And there are so much of funding available all around the world. Even in India, I have come up with the funding for the hydrogen generations. So we have to, for there are so many fundings available. So we have this final call for this for hydrogen aviation. We are all welcome for this hydrogen world. Thanks for giving me this opportunity. And yeah, thank you so much. I thank mainly Daumani ma'am for giving me this opportunity on this occasion to share some of my expertise and some of my experience on hydrogen. Thank you so much, ma'am. Thank you.
Let's extend a gracious welcome to our Honorable Dr. C. Tavamanimam, FIE, Honorary Secretary of IEI SLC, Salem, to deliver the vote of thanks. We are honored to have him express gratitude on behalf of this institution. Please welcome, ma'am.
say that